The James Webb Space Telescope made a significant revelation. What was seen by the telescope appeared to be a computer-generated glare in the depths of space. Located roughly 7 trillion miles from Earth, this groundbreaking discovery has aroused tremendous fascination with the possibility of intelligent alien life. Proxima Centauri b, the nearest exoplanet to our world, was observed by the telescope, and an unusually bright emission from the land it occupies was noted. What could account for these urban illuminations on Proxima Centauri b? Could this mean that there are advanced beings beyond our planetary system? Join us as we look into the matter. The way the James Webb Space Telescope works is remarkable. These events were captured by the telescope, revealing anomalies that occur across all of space. For years, curious minds and scientists have considered the possibility of life beyond the planet. Any indication that could attest to this long-held ambition has always been welcomed with eager anticipation. Recently, when leading astrophysicists discovered convincing evidence that life exists elsewhere in the galaxy, it was taken over by the James Webb Space Telescope and transmitted to Earth again. The eyepiece spotted strange city-like rays of light from Proxima Centauri b, an exoplanet. These glowing signs, distinguished by description, resemble the illumination of a city far away. The concept of a civilization from another planet having done well on this celestial body has left investigators amazed and engrossed. They find themselves astonished, since this might signify the landmark they have been planning for decades. If corroborated, as many assert it might be, it demonstrates intelligent construction is underway by extraterrestrial societies beyond our wildest dreams. And we are only now beginning to detect them. Contemplating this interstellar luminescence, nearly 7 trillion miles away, NASA experts are left perplexed by the absence of answers. How long might these lights have continued to wait for humanity's technological capability to perceive them? Astrophysicist David Kipping at Columbia University described Proxima Centauri b, the exoplanet where a glowing pattern emerged, as captivating. He attributed this to variations in the thermal cycles of our solar system's neighboring star system, the closest stellar companion, which is significantly different from those found on common planets. Planets with rocks generally release and absorb starlight. They radiate warmth in the infrared spectrum. However, the most astonishing clarification is that this exoplanet does not act in this manner. Its infrared fingerprint contrasts sharply with its host star, Proxima Centauri. This marks a significant outcome of the James Webb Space Telescope (JWST). Due to the fact that it can detect infrared wavelengths and examine Proxima Centauri b's radiation caused by heat. This telescope is essential for solving the enigmas of its atmosphere. Because of its cutting-edge sensors in the infrared and excellent thermal precision, astronomers plan to employ the JWST to reveal the world's atmospheric mysteries. They also intend to evaluate its potential to sustain life. The JWST's accuracy in capturing infrared light allows it to observe Proxima Centauri b's night side, discerning even the faintest glimmers in the vast distance. Although this typically presents a formidable obstacle for the majority of space telescopes, the JWST's design allows it to register the tiniest amount of radiative signatures, serves as the ideal observational facility for testing theories of Proxima Centauri b's artificial illumination on its dark section. Any non-natural light in space can be detected by this instrument if it exists within a bandwidth that is 1,000 times smaller than natural stellar light. Proxima Centauri b displays a pronounced link between its surface and astronomical phenomena. The sunlit half of the planet is believed to have numerous solar arrays that acquire power from a nearby star, while simultaneously considering inbound beams at its visible margin. As Proxima Centauri b is centered on Proxima Centauri, it undergoes day and night cycles analogous to Earth's. It experiences intense heat during daylight and cool darkness when it is night. Proxima Centauri b is identified for its effects on its thermal variation structure as a whole. For example, In the absence of a setting, the distinction between its two halves would be drastic and sudden. Without atmospheric gases to maintain a temperature buffer, the sunlit side would transform into blisteringly hot, while the opposite side would fall into freezing night. Understanding these thermal shifts is a principal goal of researchers, providing greater understanding of the tiers in the planet's atmosphere. The JWST's strong infrared capabilities make possible a comprehensive analysis of thermal signatures, allowing researchers to investigate the oddities of the planet's characteristics and learn about its climate-related mechanics. Intriguingly, the orbit of the James Webb Space Telescope aligns with Proxima Centauri B's orbital interval, permitting it to keep track of the day and night cycles on the planet in just 11.2 Earth days. If there is an atmosphere on Proxima Centauri b, the next goal is to investigate its chemical makeup to determine whether it could support life. Future observatories will target important biomarkers like the presence of water vapor, oxygen, and methane. The finding of any one of these molecules would signal life-sustaining conditions. Identifying them necessitates careful examination of how light traverses the gaseous planet strait, a significant obstacle even for sophisticated instruments, such as the JWST, which remains the foremost tool available for probing exoplanet atmospheres. Despite its exceptional sophistication, the JWST is constrained and can only carry out comprehensive assessments of a small number of the closest exoplanets. Now, astronomers are shifting their focus to massive observatories on the ground, such as the Extremely Large Telescope (ELT), projected to be operational by the year 2028. The ELT will be capable of assessing the chemical makeup of exoplanet atmospheres and the potential to produce a profound understanding of their habitability potential. Researchers at NASA and across the world eagerly await the development of even more potent space-based observatories. Before then, the JWST remains our most essential asset for revealing the truths of remote planets. Despite its present technical restrictions, the JWST continues to hold promise for groundbreaking findings that could change how people understand the universe. One of the primary aims for next-generation telescopes is to reduce the glare from the host stars of exoplanets, making it possible for astronomers to readily perceive the faint reflected light coming directly from the planets. This is expected to be accomplished through either internal stellar light-blocking devices or huge spheres used as a shade in space, comparable to shielding your eyes with your hand to better view objects against bright sunlight. Abatement of the dominant light of the host star will provide space for future instruments to isolate and examine the subtle light from distant exoplanets, which will provide a deeper understanding of their climates and possibility for life. Nonetheless, this technique comes with its own challenges we face as scientists. We must differentiate between gases arising from biological operations and those generated by geological activity, such as volcanic phenomena. Astronomers dedicate themselves to enhancing their understanding of locating exoplanetary environments, authentic indicators of life, and avoiding misconstruing false signals. The James Webb Space Telescope offers us a prelude to the discoveries that will be revealed ahead in exoplanet research, hinting at the astonishing knowledge that sits just beyond our grasp. As the investigation progresses, we improve our ability to decipher the complexity of the universe and humanity's role within it. Despite the survey, numerous celestial objects, according to experts, have yet to provide unquestionable support for life. Although they have been looking at the heavens for decades, the quest continues. The question remains, do we really stand alone in this infinite universe? Ages ago, humans speculated whether we are the lone intelligent life form. This enduring query continues to be relevant today. Researchers are currently utilizing the James Webb Space Telescope to look for signs of alien civilizations hidden across the cosmos, observing numerous exoplanets for potential life indicators. At the same time, a widely discussed theory posits that some extraterrestrial species may already inhabit the stars, idly awaiting their discovery by humankind. To aid in resolving this vexing question to American astronomers Jill Tartar and Thomas Pearson started the search for extraterrestrial intelligence SETI in 1984. This is run by the SETI Institute, a nonprofit project aiming to examine the skies for radio messages from other worlds. The utilization of radio waves is determined by their ability to travel vast distances with minimal disruption or deterioration. Contrary to other forms of electromagnetic radiation, radio communications are more likely to be detected. The 42 radio dishes of the Allen Telescope Array in the Cascade Mountains of California were able to catch signals. Although SETI has been paying close attention to communication with aliens for more than 30 years, no credible signals have been received. Jill Tartar maintains her optimism, anticipating a future where Earth's inhabitants actively participate in the hunt for intelligent life. That impression changed as a result of recent announcements from NASA, suggesting that the James Webb Space Telescope had discerned city-like light coming from a planet fairly close to Earth. The JWST is the most effective instrument in science. The human race has attempted to decipher the unsolved mysteries of life. Launched in December 2021, it is widely recognized as the most sophisticated infrared observatory built. Furnished with some of the world's best optics, the James Webb Space Telescope has the ability to pierce cosmic dust to reveal hidden features of the cosmos. Its primary objective is to look at the first galaxies and stars formed over 13 billion years ago. The telescope includes some of the most ingenious instruments currently available: a camera with a near-infrared lens, a near-infrared spectrograph, a fine guidance sensor, and a mid-infrared imager for precise spatial alignment. Its massive mirror, consisting of 18 gold-coated modules, is designed to capture dim illumination from the most distant reaches of the universe. It operates at ultra-cold temperatures, allowing detection of the most delicate thermal imprints from remote celestial bodies ever since the James Webb Space Telescope's deployment. It has produced stunning imagery of star formation, galaxy collisions, and numerous cosmic events previously concealed from view. Through the JWST's powerful optics, a brand new entrance to the opulence and complexity of the universe has been opened. The JWST continues to be a distinguishing milestone in humanity's effort to explore the frontier of space. It's unmatched resolution and sensitivity render it an essential pillar in our effort to comprehend how stars, planets, and possibly life itself have evolved across the cosmos. Scientists anticipate that with ongoing improvements in observing technology, future space telescopes may surpass the capabilities of the JWST. These new instruments may not only detect biosignatures, but also provide visual confirmation of intelligent civilizations, possibly even capturing structures or activity from societies with advanced technology. Until that time, the JWST remains indispensable to astronomy. It bridges the gap between speculative thinking and evidence, rendering ideas about life on other planets more concrete, every data transmission from its orbit around the second Lagrange point L2 brings us one step closer to answering the timeless question: are we the only intelligent beings in the universe? From its vantage point, almost 1 million miles from Earth, the JWST operates in a zone of thermal and orbital stability, ideally suited for sustained observation. Its strong gold-coated mirrors and meticulously calibrated cooled instruments are designed to detect subtle infrared signals such as those released by stars, galaxies, and distant exoplanets. Due to these features, it is able to capture celestial phenomena with unprecedented clarity. What makes this mission even more compelling is the possibility that we may be witnessing not merely signs of habitability, but of civilization itself. Not a natural phenomenon, but an artificial source of illumination. This would indicate technology-related activity. True, the civilization-like glow from Proxima Centauri b would mark the inaugural, egregious example of a society of non-terrestrial origin. Such a disclosure would have widespread consequences for science, theology, philosophy, and Geopolitics. Questions would arise. What are their goals? Can we communicate with them? Are they aware of us? Do they seem friendly?